In the second part of vectors, we want to look at how to perform operations with vectors. We want to find a unit vector in terms of its magnitude and direction, and we'll solve some applied problems. So I just want to quickly go through some of the operations here. These are really straightforward, very algebraic based. And so when you're adding two vectors together, all you need to do is add their horizontal and vertical components together. Same thing with subtraction. You just need to subtract their horizontal and vertical components. Scalar multiplication: when you multiply a vector by a scalar, you multiply a and b by that scalar value. Multiplying by 0 just basically gives you 0 components. The properties that hold true for vector addition: the commutative property, the associative property, identity, additive inverse. And the multiplication properties, same thing. For scalar multiplication, the associative property and the distributive properties hold true. The multiplication identity of 1 is still the same, and when you multiply something by 0, you get 0. You need to find the magnitude of a scalar times a vector. You take the absolute value of the scalar times the magnitude of the vector. So rather than do examples of these first, I'm going to have you pause the video and just do the student practice, because I really think this is quite straightforward, and then you can check your answers by starting up the video. And as always, I recommend if you feel like you know and understand how to do the problems, you don't have to watch the whole solution. You can fast forward to the end of the video so that you can just see what the answers are and check your work. And if you get something wrong, you can always go back and fix it. So take a few minutes to do these few problems and then check back. So for part A, if I want to add the two vectors u and v, I add their horizontal components and their vertical components. So I'm going to take 3 minus 4, so I'm going to get negative I, and then negative 5 plus 2 would just give me negative 3j, so I'd want to rewrite that as negative I minus 3j. Remember that in addition to writing a vector in component form using a linear combination, you can use angular brackets to represent that same vector. So this would be the same vector as this right here. For part B, if we want to do v minus w, remember that to subtract two vectors, it's the same thing as adding the opposite. So I'm going to take v, which is 3i minus 5j, and I'm going to add that to the opposite of vector w. So that would be negative 7i plus j. And when we add the horizontal and vertical components together, we get negative 4i minus 4j. To take negative 3v, we're going to multiply each of the components of v. We have negative 3 times 3i minus 3 times negative 5j. So we're going to have negative 9i plus 15j. And as a review, to find the magnitude of w, it's just going to be the square root of a squared plus b squared. So it's going to be the square root of 7 squared plus negative 1 squared, which would be the square root of 50, or 5 square roots of 2. And then the last one, all right, for part E, I first want to find negative 2w, which is going to be negative 2 times 7i minus j which is going to be negative 14I plus 2j. If I find negative 6u, I'm going to take negative 6 times negative 4I plus 2j, which is going to be 24I minus 12j. I need to combine these two together. So I've already taken the opposite, right? I'm adding the opposite, so I'm going to get 10I minus 10j. Now what I have to do is take the magnitude of that, which is going to be the square root of 10 squared plus negative 10 squared, which would be the square root of 200, or 10 square roots of 2. Unit vectors are very useful in solving applications, and what's even more useful is to be able to find a unit vector that has the same direction as some other vector. And in order to do that, you're basically just going to divide the vector itself by its magnitude. So if you look right here, v divided by the magnitude of v, it's going to give you a unit vector that has the same direction as v. So looking at example 5, first thing I'm going to do is I'm going to find the magnitude of vector v, and I do that by taking the square root of 3 squared plus negative 4 squared. It's going to be the square root of 25, or just 5. And we know that to find that unit vector, we're going to take v and divide it by the magnitude of v. So vector v is 3i minus 4j, and to divide by 5, we're just going to divide each component by 5, giving us this new vector 3/5 I minus 4/5 j. So what we've just created is a vector that has a magnitude of 1, because we're creating a unit vector, but it should also have the same direction as our original vector. So let's just double check that. The first thing I want to do is check the direction. And I know the direction of v is just going to be negative 4/3, right? That's going to give me my direction. It's just the slope of that vector. And now what I want to do with my new vector is to check the direction. So I'm going to have, just going to take b, and divide it by a. The 5's cancel. I get negative 4/3. So I know that these two vectors, the 3/5 I minus 4/5 j and the 3i minus 4j, have the same direction. Now the next thing I need to do is make sure that my new vector has a magnitude of 1. So I'm going to find the magnitude of this new vector. So I'm going to take 3/5 and square it and add it to negative 4/5 squared. It's going to be the square root of 9/25 plus 16/25. It's going to be the square root of 25 over 25, which is equal to 1. So we have created a unit vector that has the same direction as a given vector. Right, so pause the video, try student practice 5, then come back and check your answer. All right, now let's find the vector, or the unit vector, that has the same direction as vector v, which is I plus 8j. So we'll first find the magnitude of v, which is going to be the square root of 1 squared plus 8 squared, which is the square root of 65. Then I'll take vector v, divide each component by the square root of 65, giving us 1 square root of 65I plus 8 over the square root of 65j. We want to first check and see that the direction is the same. I know that the direction of the original v is going to be just 8 over 1, right? A over b. The direction of the new unit vector is going to be 8 over the square root of 65 divided by 1 over the square root of 65. When you multiply by the reciprocal, the square root of 65 cancels, you just get 8 over 1, or just 8. Now let's confirm that this is in fact a unit vector by checking the magnitude. So the magnitude of the new vector is going to be the square root of 1 over the square root of 65 squared plus the 8 over the square root of 65 squared. This is going to be 1 over 65 plus 64 over 65, which is going to equal the square root of 65 over 65, which is equal to 1. So we've confirmed that we have a unit vector, and we've confirmed that the direction is the same.